Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from Dwarkesh Patel. Dario Amodei, CEO of Anthropic, delivers a set of predictions that challenge nearly every assumption the AI industry operates under. He claims that turning a profit today signals strategic miscalculation, that human algorithm design contributes almost nothing to intelligence, and that the arrival of superintelligence will be throttled not by computation but by regulatory friction. His framework discards conventional business logic in favor of raw scaling mathematics. Here's his analysis. Dario Amodei, CEO of Anthropic, recently presented a series of predictions that systematically dismantle the operating assumptions of the AI industry. His positions sound extreme. Profitability is evidence of failure, human ingenuity as statistically irrelevant, and superintelligence delayed not by technical barriers but by bureaucratic inertia. Yet he frames these not as provocations but as mathematical inevitabilities derived from scaling laws. His engineering worldview begins with what he calls the big blob of compute hypothesis, a position he has maintained since 2017. The AI research community celebrates architectural innovation, novel attention mechanisms, refined training techniques, sophisticated data curation. Amodei dismisses this entire domain as noise. His framework reduces intelligence to 7 variables: raw compute, data volume, training duration, and a handful of other scalable inputs. Feeds sufficient computation into a system with a scalable objective function, and the model learns autonomously. This framework relegates human cleverness in algorithm design to marginal relevance. Intelligence, in his model, is not craftsmanship, but industrial scale resource deployment. The implication violates the identity of computer science as an intellectual discipline. The breakthrough is not in the elegance of the method, but in the magnitude of the engine. This engineering reductionism leads directly to an ontological redefinition of what these systems represent. The prevailing mental model treats AI as software, a productivity tool, a better search interface, an assistant. Amodei rejects this categorization entirely. He describes the endpoint as a country of geniuses in a data center. He assigns a 90% probability to this outcome within 10 years, though his intuition places it closer to 2026 or 2027. This is not hyperbole. He means a system with intellectual capacity exceeding that of Nobel laureates across all disciplines, available in infinite quantity, operating continuously. The shift here is categorical. AI transitions from a product humans deploy to a population humans coexist with. If millions of world-class experts reside in a server rack, the constraint on solving cancer or achieving fusion energy ceases to be intelligence and becomes purely physical implementation. This redefinition forces a reconsideration of labour markets, particularly for software engineers. The reassuring narrative positions AI as a co-pilot. It accelerates code generation, but humans retain architectural control. Amodei views this as a temporary phase. He distinguishes between AI writing 90% of the lines of code and AI performing 100% of the job. Currently, humans manage context, requirements gathering, system design, compilation, deployment. He forecasts that models will soon handle the entire workflow end to end. They will not merely autocomplete syntax, but navigate interfaces, execute tests, debug failures, and ship software autonomously. This collapses the assumption that creativity or strategic planning protects knowledge work. In his analysis, these are simply data processing tasks that fit within the context window of a sufficiently advanced model. His economic logic produces inversions that contradict standard business metrics. In conventional corporate strategy, profitability signals health. Amodei argues that in the current AI phase, profitability indicates a forecasting error. His reasoning centers on the extreme supply-demand imbalance in compute. If a lab is profitable now, it means they underestimated demand and failed to purchase sufficient GPUs for the next training run. The optimal strategy during a winner-take-all exponential growth phase is to reinvest every dollar and more into the next generation of compute. A balanced balance sheet, therefore, is evidence that a company is moving too slowly to capture the future. This inverts the Wall Street equation, where quarterly earnings equal corporate strength. Immediately following this, he introduces a constraint that contradicts the race at all costs mentality, the bankruptcy trap. The intuitive response to an imminent AGI timeline is to purchase trillions of dollars of compute immediately. Amodei identifies this as a fatal mistake. He separates technical capability from economic diffusion. Even if the country of geniuses arrives in 2027, the economy may require 1 or 2 additional years to integrate it. If a company commits to $1 trillion compute expenditure based on a 2027 revenue projection, and the revenue materializes in 2028 due to institutional lag, the company collapses. They were correct about the technology, but wrong about the speed of human adoption. This creates a paradox. You must bet on the exponential curve, but if you are even 6 months premature, you are eliminated. Here's analysis of physical and regulatory constraints introduces a final friction point. The default techno-optimist assumption holds that superintelligence will instantly solve humanity's problems. Amodei presents a deflationary scenario. The AI invents cures for every known disease within weeks. The intellectual work is complete, yet actual disease eradication requires years, not because of scientific limitations, but because of the FDA, manufacturing logistics, and clinical trial requirements. The bottleneck shifts entirely from discovery to permission. This produces a high-friction future where the blueprints for utopia exist on a hard drive, but legal and physical systems prohibit rapid implementation. It challenges the singularity narrative as an instantaneous event. Instead, it becomes a protracted conflict between digital speed and analog bureaucracy. Amodei's analytical framework reveals a consistent methodology. He strips away human ego and social conventions to examine raw scaling laws. If the compute curve predicts an intelligence explosion, he accepts it, regardless of whether it resembles science fiction or violates economic norms. He envisions a world where technology advances at the speed of light while human institutions and human comprehension remain gridlocked. The central question, if this country of geniuses is indeed arriving within 24 months, are we preparing for the reality of the technology, or are we still operating under the assumptions of our outdated mental models? If you're interested in the video featured in this episode, click the link below to watch the original.